Poisson distribution. Poisson distribution was developed by the French mathematician Simeon Denis Poisson in 1837. What is Poisson distribution? The Poisson distribution is a discrete probability distribution for the counts of events that occur randomly in a given interval of time. Many experimental situations occur in which we observe the counts of events within a set unit of time, area, volume, length, etc. For example, the number of cars passing a certain point in 1 minute, the number of defective electric bulbs manufactured by a reputed company, number of telephone calls in a week, number of people arriving at a checkout in a day, number of industrial accidents per month in a manufacturing plant. Probability mass function of Poisson distribution. The probability of observing X events in a given interval is given by probability of X is equal to e power minus lambda, lambda power X divided by X factorial. X to the values 0, 1, 2 and so on, infinity. Here E is the mathematical constant. The value of E is 2.7188. Poisson process. Poisson process is a random process which counts the number of events and the time that these events occur in a given time interval. The time between each pair of consecutive events has an exponential distribution with parameter lambda, and each of these inter-arrival times is assumed to be independent of each inter-arrival times. For example, here a typist makes on average 2 mistakes per page. What is the probability of a particular page having no errors on it? The mean of the binomial distribution is lambda. Here the lambda is 2 mistakes per page. The probability mass function of binomial distribution is e power minus lambda, lambda for x divided by x factorial. Here lambda is 2 and x is 0. Substitute these values in our given formula, then we will get the 0.135. So here we have the 0.1353 is a chance to get there is no mistakes per page. One more example, a computer crashes once every 2 days on average. What is the probability of there being 2 crashes in 1 week? So here the average value is 2, x takes the value 2. So substitute these values in the probability mass function of Poisson distribution, then we will get the probability of getting 2 crashes in 1 week is 0.2707. The mean number of falls in a new house is 8. What is the probability of buying a new house with exactly 1 fault? So here the average falls are 8. The probability of x is equal to 1. Substitute here the lambda is 8 and x is 1, then we will get the 0.0027. Consider in an office 2 customers arrived today. Calculate the possibilities for exactly 3 customers to be arrived on tomorrow. So depending on today's data, we are trying to identify what's the chance we have to get the 3 customers for tomorrow. So probability of x is equal to 3. Here average the lambda is 2. So e power minus 2, 2 cube divided by 3 factorial is 0.1805. Hence, there are 18% possibilities for 3 customers to be arrived tomorrow. Births in a hospital occur randomly at an average rate of 1.8 births per hour. What is the probability of observing 4 births in a given hour at the hospital? What about the probability of observing more than or equal to 2 births in a given hour at the hospital? See here, let x is the number of births in a given hour. So the first one we're going to calculate the observing the 4 births. So here x is 4 and then the lambda is 1.8. It's the average rate given in the question. So substitute the lambda value and x value in the probability mass function of the Poisson distribution. You will get the 0.0723 is the chance to observe the 4 births in a given hour. Then more than or equal to births in a given hour. Symbolically we will write it is the probability of x is greater than or equal to 2. Then probability of x is equal to 2 plus probability of x is equal to 3 and so on. We can write it is like a 1 minus probability of x less than 2. So the 1 minus probability of x less than 2, we have the two observations x is equal to 0 and x is equal to 1. Then substitute the values. The lambda is equal to 1.8 and the x is 0 and when x is 1. Then 0.537 is the probability value the more than or equal to 2 births in given hour. Consider a computer system with Poisson job arrival stream at an average of 2 per minute. Determine the probability that in a 1 minute interval there will be 0 jobs, exactly 2 jobs, at most 3 arrivals. No job arrivals. No job arrivals, that is x is equal to 0. Then substitute the values here in the given question. Lambda is equal to 2. The probability mass function of the Poisson distribution e power minus lambda, lambda power x divided by x factorial. Here x is 0, so e power minus 2, 2 power 0 divided by 0 factorial. Then 2 power 0 is 1, 0 factorial is also 1. Then you will get the e power minus 2. The value of e power minus 2 is 0.135. So we have the probability of occurrence. No job arrivals is 0.135. Exactly 3 job arrivals. The same way we have to substitute the x is equal to 3 and the lambda is 2, the given formula. Then we will get the 0.18. Then at most 3 arrivals. So symbolically we will write it as at most 3 arrivals. The probability of x is less than or equal to 3. Then the probability of x is 0 plus probability of x is 1 plus probability of x is 2 plus probability of x is 3. We substitute the values of instead of the x is 0, 1, 2, 3 and lambda is 2 in the given formula. Then we'll get that 0.8571 is a chance the occurrence of at most 3 arrivals. Fitting a Poisson distribution to observed data. The following table gives a number of days in a 50-day period during which automobile accidents occurred in a city. Here the number of accidents 0. 0 indicates there is no accidents. 21 days no accidents in the 50-day period. So 1 indicate 1 accident happened in 18 days. The 2 accidents happen in 7 days, 3 accidents happen in 3 days, 4 accidents happen in 1 day. Then this is the data we have. The x takes the value 0, 1, 2, 3, 4. The corresponding frequencies are given in the question. Then calculate the average lambda. The Poisson distribution lambda is the mean. And generally we have the formula to calculate the mean. X bar is equal to summation of x divided by n. So here it is the table column 3. Calculate the values for the f into x. The sum of the f into x is 45. So 45 divided by, then the frequency is 50. 45 divided by 50 is equal to give the value 0.9. So the average of the Poisson distribution lambda is 0.9. In order to fit Poisson distribution, we shall multiply each probability by n. Hence, expected frequency is already the x is given in the question. Calculate the probability of x for each and every x by using the formula here. The lambda value already we calculated. The lambda is 0.9. Then the probability mass function of Poisson distribution is equal minus lambda power x divided by x factorial. Here the lambda is 0.9 and the x is, when x is 0, the substitute the value in the place of x is 0, we will get the probability value is 0.4066. The place of x is 1, get the probability value is 0.3659. In the place of x is 2, get the probability value is 0.1647. And substitute the x is 3, the probability value is 0.0494. To substitute the x is 4, the probability value is 0.0111. These are the probability values, and this f is the expected frequencies. The expected frequencies will calculated by using the formula n into probability of x. Already we calculated the probability values. Then multiply these probability values with n. The n is 50 days. N is 50 days. So multiply each probability with n. These are the frequencies we get it. Then take the approximate values for these frequencies. Then that should be equal to the 50. Right. So here we can consider it is a 20, 18, the approximately we take it as a 8, and it is approximate I'm taking it as a 5, and this is sorry, it is a 2.5, that is 3, and this is 1. Let me check it. So the total is equal to 50. So what are the frequencies they given in the question? That are the observed frequencies. These are the expected frequencies. So the observed frequencies are, the number of observed frequencies are equal to that number of expected. Then the total observed frequencies are equal to the total expected frequencies. Then he said that data is correct fit to the Poisson distribution.